Hello YouTube viewers, welcome to my channel Science Trader. Today we're gonna have a very important real world discussion is 3D printing only good for knickknacks or actually useful thing. Now I have already made 3D printed useful parts for electronics and all that, but today I'm gonna push it a bit further, bit outdoor so to say. So I have this shade. Now this shade is utilizing basically square box tube. So utilizing that, I have to create a basically tube clamp. Now I do not want to drill on the basically box. Again, there are drill holes into it, but that is only used for the shade, and I do not want to drill there. And I want to do this with minimal damage to anything, neither the tube nor the basically the frame. So let's go to the computer and design something that allows us to do basically proper 3D printing. So let's talk about the basically tube lights. So just for thoroughness sake, I have bought two of them. One is Anchor, one is Havells, and both are around 20 watt LED tube lights. They are T5. Now power factor on them is 0.9. I wished a bit more, but okay. It's better than 100% useless Chinese one, because again, if you want to run them on inverter, power factor does matter. If you have poor power factor, it will not be good. Now what about the light output? Yeah, that part is bit underwhelming, because you can see it's around 100 watt per lumens. Nowadays you should be able to get 200 watt per lumen. So but they were cheap, so I'm not too upset about that. And the tube lights are basically the same design. They are basically commercial T5 tubes. Only difference is for residential use they give the pigtail here, but if you bought the commercial one, they will have a jack here, so you can daisy chain them. One of them does feel a bit cheap and loose, another one is a bit strong. I'm more likely to use Havells one because it's white and it's outdoor and in India, so any color that can absorb heat is not desirable like this puppy. So I'm more inclined to go with Havells, and it does feel a bit more robust. But again, I'll put it, test it. If it does not last, we'll know. So this is the whole point. T5 tubes, T5 or T4. It's like I always get them confused. So all I have to do in 3D printing is basically print these puppies. So this basically metal flanges, I have to design them in 3D printings in such a way that it's A, tolerant enough so it actually grips the tube. B, it actually is springy enough where I can put in the tube and pull out the tube. And let's hope for the best. So now let's go to the PC. So let's start to develop this sketch for actual 3D printing. Now be mindful, you can design whatever you want in a CAD, but problem is you will get what we call CAD eye. You mean basically you will give details and small things that only you can look into CAD, but a 3D printer may not be able to print, or CNC machine cannot machine it. So for that reason, you have to be a bit realistic. So the best way to do it is be mindful of sizes. For example, let's say this is the clamp that I'm designing. How thick the wall should be. Now you may think like, hey, 2mm should be good enough. Hey, still, where did you get that 2mm? There is no 2mm in the basically printer, unless you have a nozzle that is exactly 1mm. But here's the deal. What you have to do is do something like this. Basically, in my case, my print head is 0.4mm. So any height that I'm choosing, or basically any thickness I'm choosing, must be multiple of that. So first I tried with 4 and I find like, that was a bit flimsy, so 6 it became. And benefit of using even numbers are like when I'm going from that size to a sphere, or basically rounded object, this size could be basically 3. 3 lines goes one way, 3 lines goes that way, and it's a complete circle. Be mindful, you have to also understand where the gravity is pulling from. So if gravity is, let's say, pulling in this direction, now if every plastic strand is in one continuous loop, I can trust it. I can be like, okay, I got this. Because if you print it in a different orientation where the layer lines are not aligning, yeah, it's gonna fall apart. So, and this sort of shape, even though you can 3D model it, you should not do so. For example, let's say I go here. Okay, and I activate the bodies. Okay. Okay. So if I try to print this or slice this, computer will slice it. As in like if you look into preview of the mesh, it will look sense, but this is not a good thing, because again, there will be stress concentration and plastic will become bitter and fatigue here. So you add chamfers to it. Now this way, now the plastic has an easy way of doing it. If you want to be really pedantic about it, you can even slice from the inside, basically give a small curve inside, so it has like full flow. So 3 lines will come in, 3 line will take a smoother. So what does that mean? That simply means like this. So now you take it into your slicing software, you slice this puppy. Now be mindful, all software will give you preview option. Always preview the damn thing. Now you see, You see how smoothly each lines are. And be mindful, do not try to give 90 degrees. Be have some subtle curve or smooth curve. Like I had the luxury, so I gave a very smooth curve. This is much more robust compared to having hard joints, because again, when you try to do hard joint, it tries to do a retract and push when it changes direction. It's not a good smooth flow. You want smooth flow, you know. So a smooth flow is you get smooth. And here you get like, now be mindful, because I have wall thickness set to 8, I'm getting this. You may not get it. So increase your wall thickness. Again, this is a structural component, meaning in this direction I want it to be like pulling, because there won't be any load in this direction. The layer lines, the lines that you see, it there is none. It's just a glue thing where it's like, okay, I'm sticking together. So it's more than good enough. Be mindful, layer lines are not what you call 100% weak, but they are like, you should not count on them. But in this direction where it needs to retain the shape, it's more than good enough. So this is how to. I did thought of like making this way too slanted, but it was like reaching stupid layer where if I could get a, it was not robust enough. So some amount of sport material was needed. Now, this is the main shape that will go around the box. What the hell is happening? Yeah. But before I did that, I had to print the clips, basically these things. Do not directly try to model a complex objects. Do not do that. You will waste too much time and you will hate yourself. So, like for example, uh-huh. So if I directly try to model this, it would not have worked out because I would not have known. So I started to making basically clips like this. Then I tested it on my real world object and it did not work. So I created another one. I made it smaller and shrink it. Now, ta-da! Now I got the comfort side. And be mindful, the reason why the clamp is like this weird shape is basically it's doing this. Pushing through this and pulling through this. So now if you only have hangers like this, if you're just like, okay, hang down like this, it will be hanging. Like gravity will hold it there, but it will jitter. Like if there is a little bit of it will, because it's a loose fit. And if you pay attention to the metal clips, so metal clips, why do you think they are in that weird shape? The reason is it is pushing and pulling. So that way you lock it. So you pull it from the ears. You are pulling from the ears and you're pushing on this side. Like maybe you can see it. Like there is a little bit of push here in this clip. That's how you are making sure that does not jiggle, jiggle, jiggle. It's a robust clip. Now you print a big one. Now you're like, I got this. So always test in small scale. Always make sure your diameters are like thickness and diameters are logical. Do not, and please make sure you do not get stuck in CAD. Always look in the slicer software and in preview, so you can get an actual idea. Can it be printed? Will it be strong enough? Only then you can move to actual printing. Now I'll show you guys the actual printed parts. So this is after the printout. I got all my 4 printed out. Now I'm using M3 because again that's what I have. You can use M4, but generally it will become too thick. And you can see it was printed like this. So print lines are completely what you call in the structure, like basically in gravity, in pulling it's solid, meaning if you lock it like this, like it's not coming out. Now what about this clamp? That's why I said like you always supposed to print a small one. I printed it, then found out this was like, too loose, it's not gonna do. Then I printed a bigger one just to test out that. Ta-da! And that's what I was talking about, like there has to be a bit of spring force. And let's put some big ones into this. Now in the last part where I'm gonna actually hang it, I'm not gonna talk, simply because again talking while I'm hanging, it's unwise. So come on. Yes. So why 4? Well, 2 should be more than sufficient enough, but I do want, and again, see, because of that spring design, it's pushing it down and it's not rattling. That's a design feature. I want that. No, let's see. And ta-da! So now let's go and mount it. Well, turns out because of the screws that are here, I can't use that, can't use this one, and can't use this one. So I think only 3 is mountable. So that's a test of 3 clamps. Let's see. Ta-da! It is working, it's functional, and now you will have some idea how to design something that is meant for actual heavy use.